Hey, so today we're going to do PowerPlants and Aircraft Systems, PowerPoint A. First, let's look at the reciprocating engine, also known as the piston engine. It is typically a heat engine, although there's also some pneumatic and hydraulic reciprocating engines as well. They use one or more reciprocating pistons to convert pressure into a rotating motion. This is one of the types of planes that would use a reciprocating engine. So turbojet engines, we'll come back to those in a minute. Now let's look at the four-stroke operating system. In the first step, you've got an intake stroke. Air and fuel enter the small engine through the carburetor. It's the job of the carburetor to supply a mixture of air and fuel that will allow for proper combustion. During this intake stroke, the intake valve between the carburetor and the combustion chamber opens. This allows atmospheric pressure to force the air-fuel mixture into the cylinder bore as the piston moves downward. Second step is the compression stroke. Just after the piston moves to the bottom of its travel, the cylinder bore contains the maximum air-fuel mixture possible. The intake valve closes and the piston turns back up the cylinder bore. This is called the compression stroke of the four-cycle engine process. This air-fuel mixture is compressed between the piston and the cylinder head. Now we're on to step 4, the power stroke. When the piston reaches the top of its travel, it will be at its optimum point to ignite the fuel to get maximum power. A very high voltage is required in this ignition coil. The spark plug enables this high voltage to be discharged in the combustion chamber. The heat created by the spark ignites the gases, creating rapidly expanding superheated gases that force the piston back down the cylinder bore. This is called the power stroke. And final step 4 is exhaustion stroke. When the piston reaches the bottom, the exhaust valve opens. As the piston travels back up the cylinder bore, it forces the piston combustion gases through the exhaust valve and out the exhaust systems. As the piston returns to the center, the exhaust valve closes and the intake valve opens, and the four-cycle engine process repeats. Okay, now let's move on to revolutions per minute, also called RPMs. It's a measure of the frequency of rotation, especially the number of rotations around a fixed axis in 1 minute. It is used to measure a rotational speed of a mechanical component, such as the number of cycles in a four-stroke engine. Okay, now let's look at the International Standard Atmosphere at sea level. So the ISA is an atmospheric model of how the pressure, temperature, density, and viscosity of the Earth's atmosphere change over a wide range of altitudes or elevations. This has been established to provide a common reference for temperature and pressure, and it consists of tables and values of various altitudes plus some formulas by which these can be derived. The International Organization of Standardization, which is the ISO, published the ISA as an international standard. Other standard organizations, such as the International Civil Aviation Organization, the ICAO that we've talked about before, and the United States government, published extensions or subsets of these same atmospheric models under their own standard making authority. Next thing it asks us to talk about is the standard lapse rate. The lapse rate is the rate at which the Earth's atmospheric temperatures decrease with an increase in altitude, or they increase with a decrease in altitude. Lapse rate arises from the word lapse in the sense of gradual change. Although this concept is most often applied to Earth's troposphere, lapse rate can be extended to any gravitational supported parcel of gas. As with the aircraft goes up in elevation, the temperature in turn goes down. For every 1,000 feet an aircraft climbs, it is calculated to have a drop of 2 degrees Celsius. And if you'll look on your table, you'll see this. The average pressure at sea level is 29.92 inches of mercury at 15 degrees Celsius. As your elevation or your altitude goes up every 1,000, you'll notice the pressure has dropped to 28.86 and the temperature has now dropped to 13 degrees Celsius. Now we're talking about air, wings, and engines that they also need air. I love this. It's all about the air density. It says how many molecules of air can you get to flow across the wing to produce lift, and how many air molecules can you get to mix with the fuel to run the engine. I would write this down in my notes. The more across the wing, the greater the lift. The more you have going into the carburetor, the greater the power. I'll give you a second to do that before I move on. Next, we're going to talk about carburetors. All right, I'm moving on. Now let's look at this carburetor. A carburetor is a device that blends the air and the fuel for an internal combustion engine in the proper ratio of combustion. The ratio that I've found is 4.7 pounds of air for every 1 pound of fuel. To carburate, which I thought this was really interesting, and this carburation is to blend air and fuel or to equip an engine with a carburetor for that purpose. The burette part of carburetor is equipment for measuring liquids accurately. So I thought that was just kind of a neat way to figure out how all that works. So carburetor is the blending of this air and fuel. Carburetor is measuring of those liquids accurately. Carburetors have largely been replaced in automotives and, to a lesser extent, aviation industry by fuel injection. They are still common on small engines for lawnmowers, rototillers, and other kind of equipment like that. That's where I'm going to stop for today, and we'll take up the rest of the PowerPoint tomorrow. Y'all have a good day.